So now we are going to see the stack operations, which is a stack is an abstract data type. The basic idea of the stack is we can use the stack in one end only. So the last in first out. In that thing only we can insert or delete the element at the end of the stack. So which one is inserted as the last, that is only deleted from this stack. So this is like a deck of cards or plates are present. So once we have inserted one plate into the deck, means we can insert the plate only to the a plate which is inserted as the last, not to the first one. If you are inserting the first one, means we need to lift all those first set of plates, and then we can put it in the lower end. So but the stack is not like that. Which one is inserted as the last, that is to be um, accessed first. So like all other data structures, the insertion and deletion and the searching of the item and how to display those items, that is a common operations present in the stack. So the stack operations are when you are inserting an element into the stack, that is called as push, and the pop is the we are deleting the element. So last in, that is last element is pushed into the stack, and that element is first out from the stack, that is called as pop. It may be either or fixed size or the dynamic size. So peak and size is empty or the other kinds of operations. The peak is the top element in the stack, it will return which one is the top element in the stack, and the size that it returns the total number of items present in the stack. So the is empty in the sense whether the stack is empty or not. If it is empty, it will return true, otherwise it will return false. So how we are representing the stack using array, in the sense the stack is represented as a bucket. So up to the red level the elements were filled, the blue levels or elements are not at all filled. So that is the representation. When you are pushing that element, the top is increased. Okay, this is that animation we have seen. So when you are doing the pop operation, when you are doing the pop operation, that will eliminate the top element, and the size of the stack is reduced, that is the pop operation. Okay, the top is the only thing which is used to represent the end of the stack. So the push, in the sense we need to verify whether the stack is full or not, because before we are going to insert any element into the stack, we must verify whether the stack is full or not. If the stack is not at all filled, we can insert an element and the top is incremented by the 1. So the push operation takes O of 1 running time. Okay, this is the implementation. So the element to be inserted is passed as an argument to the push, and we are checking the useful operation for the completion of the stack size. If it is full, means we just display as the overflow, otherwise inside the array we are just increment the top and then inserted the element into the top position. Okay, pop in the sense, so while you are inserting an element, we need to verify whether the stack is full or not. While when you are doing the popping operation, you must verify whether the stack is empty or not. Stack is empty in the sense we don't know whether that element is present or not, that's why we are checking the empty or not. After checking the element is stack is not empty, we are just take an item from the stack and then reduce the size of the top by -1, because before accessing the element we cannot reduce the top size. If we reduce the top size, means we will get the element at the second position after the top only. So we need the top as the last element in the stack, that's why we are accessing the element and then reducing the top. And the pop operation is also takes the O of 1 time. This is the implementation. Here we no need to pass any argument, because we are just deleting the element, we don't have the element to insert. And is empty, if the stack is empty, means we just display the content as underflow, and then we are deleting the element, which means that the top is reduced by -1. And the peak operation in the sense which one is present at the top. So stack of top, if a top is -1 means the stack is empty, otherwise we can get the element that item is returned from this function. This will also have the time or complexity of O of 1. Okay, this is the coding. So in this coding, if the element is not empty, the stack is not empty, the array of top is returned. If it is empty, -1 is returned. And is full is empty, as we know, is empty in the sense top is -1, is full in the sense the top is equal to size -1, because we are starting the top element from the 0, that's why size -1 is checked. So this is the overall implementation. In the C++, the implementation is given the class, and the here we are having the array, then top and the size of the stack. The stack is initialized with the size and the top is -1, while once you are inserting an element, first element, the top is incremented by 0, then push, then pop, then peak, then is empty, is full. This is the sample operations of the main. The applications of stack is the direct applications, and the direct application in the sense, earlier do we visiting lots of pages in the web browser, that should be added over the stack, because we need to access, we need to redo the content based on the one last we have visited. So that is the direct applications. And when undoing the text editor and Java virtual machine method calls and validating the XML, all those things are direct applications. Indirect in the sense this is a data structure for algorithm, and it may be also used as a data structure for the other component for the other data structures also. So another one example is infix to postfix evaluation. So infix in the sense operators are placed in between the operands. Postfix in the sense appear after the operands. So no precedence rules to learn in the postfix notation, and parentheses are never needed. So infix to postfix. These are all the example. For example, a plus b star c plus d in the sense ab plus cd plus star. Okay. So this is the example how we are converting a plus b into the second statement. So here b into c is first done, and then a plus b into c, then plus d. Okay, this is the example. So how we are doing the conversion in the sense, we scan the sequence of operators and operands from left to right, output the operand, because we are going to convert the infix to postfix, we must represent the operands first, and then we are going for the operators. So the operators are pushed into the stack. The stack is used to hold the operators only. So push an operator of higher precedence if the operator inside the stack is lesser than the operator inside the expression, means we can push that operator. Otherwise we need to pop an operator till that top of the stack will contain the operator which is lower precedence, and they push the present operator. So this is the algorithm. Okay, the incoming symbol is the left parenthesis, push into the stack. If the incoming symbol is right parenthesis, pop the element from the stack until the left parenthesis reached. If the incoming symbol has higher precedence than the top of the stack, push into the stack. Okay, we need to insert an element which has the higher precedence comparing to the element present in the stack. If the parenthesis in the sense, we need to pop the elements up to the open parenthesis come. If the close parenthesis in your expression, you need to pop the element up to the open parenthesis come. If the symbol is a lower precedence, then the top of the stack, so to pop the element from the top and the print that element. The next test the incoming operator against a new top of the stack. So we need to check once again. So repeat the process until all the elements are processed in the infix operation. So operands which is added to the postfix, close parenthesis, pop until the open parenthesis came. Operators, if it is a higher precedence, push into the stack, lower precedence, pop from the stack. So end of the input, all the remaining symbols are popped out from the stack. So here the operations are a into bracket of b plus c into d plus e. So the first a is added to the postfix, star is inserted into the stack. When the open parenthesis come, it just added into the stack. Then b is added to the b is added to the postfix expression. Then plus came. Plus is lower added to the stack, and the star is a higher precedence comparing to the plus, so it is added. Then for the d is added to the postfix. When the closing operators over close parenthesis come, we need to pop the elements until the open parenthesis. So star and plus is popped, remaining one is star inside the stack. Then plus will came, plus is the lower precedence comparing to the star, so the star is popped out. Then plus is inserted. After the plus is inserted, we are having e only. So after e, the other elements present in the stack is plus, which is popped. So these are all the, in this video we have seen what is a stack and what are the operations present in the stack, and an application of stack, which is how we are going to convert the infix to POSIX expression.